Hello, I welcome you to this tutorial video. This is video number 1 of Unit 2 in our series on CPN Tools software. In this video, we will build our first colored Petri net model using CPN Tools. This video covers the following topics. We'll discuss color sets, both primitive and user-defined. We'll also discuss arc expressions. We will build these arc expressions using constants and variables. And we will also look at transition guards and see what role they play when the Petri net model with guards is executed. And we will do some of these things using a version of a Hello World example.
Let us now build our first executable Petri net model in CPN Tools. I've already created a simple Petri net structure for this illustration. If you observe, I have stored this model in the file called myfirstpnmodel.cpn, which is listed in the index part of the interface. This structure has a single transition T1 with two input places P1 and P2 and an output place P3. You may have noticed that the places, transition, and arcs in this structure have a shadow around them. This is an indication that the structure is not complete and requires net inscriptions. In CPN Tools, every place must have a color set assigned to it. A color set is like a data structure that describes what tokens can be put in a place. These color sets are defined in the standard declaration section under the file name. So let me go and show you where those declarations are. If you click on this blue triangle, it opens all the attributes attached to a file, and one of those sections has all the declarations in it. So it says standard declarations, and you see some of the color sets already defined over there. For example, we have color set unit, color set integer. If we click on this triangle, it shows us more information about those color sets. Color set bool is of type boolean. Color set string is of type string. It will contain strings as members of this. We can use these color sets or define new ones for our model. For our first model, we will use the string color set, the last one in this list, for all the places that we have in our model, P1, P2, and P3. A string is any sequence of characters enclosed in double quotes, and we'll see how to create some strings and use them as tokens. In order to assign a color set to a place, we first select a place by left clicking on it. So if I left click on P1, I select the place, then we hit the tab key once. So if I do that, we see that the color set region of this place has been highlighted. That's where we type the color set name. Since we have decided to use a string, we'll type a string over here. We'll use the same color set for all the places. So I'll do the same thing, left click P2, hit the tab key once, type a string over there. Similarly with P3, tab once, and type string over there. This has assigned the color set string to all these places, and you may have noticed that the yellowish shadow around these places have disappeared, which is an indication that these places have the required color set attached or assigned to them. Now if you like, we can add some tokens to these places. Although we need to add more net inscriptions to this structure, but we can add tokens to these places because these places now have color sets assigned to them. So let's put some tokens in P1. In order to do so, we have to select the place by left clicking it, hit the tab key this time twice, once for the color set, and second times it takes us to the region where initial marking or tokens can be added to this place. Let's add one token, one backcode. This is a backcode grave accent Please note this thing. It's not a single quote, it's a back quote. On my keyboard, it's on the same key that has tilde character on it. So one back quote and a string in CPN tools is any sequence of characters enclosed in double quotes. So I'll put hello over here, double quote, and clicking my mouse anywhere on this page will add this token one hello in this place. The next thing we will do is to add inscriptions to the arcs. An arc inscription in CPN tools on an input arc determines what number and value of token or tokens are required in that input place to enable a transition. For example, if we put one hello on the arc which connects P1 to T1, now with this arc expression, one back quote hello, the token in the place also has the same token in it, and therefore transition T1 has its enablement condition fulfilled from P1. This transition is still not enabled because we need to add more inscriptions to other arcs. But one hello on this arc determines that this transition T1 would require a token of this value in the input place P1 for this transition to be enabled. I think we have a grave accent back quote missing in this arc expression. Once we do that, we have our expression on this arc. Let's add expressions to the other arcs. Suppose I put one back quote and word on the other arc, and similarly at the output I put the whole phrase hello world with a space in the middle. And now you see all the arcs, since they have the arc expressions which are syntactically correct, now have lost that shadow. Now this PetriNet is ready to be executed. We need to add some tokens in place P2 for T1 to be enabled. So let's just add one token over here, and that token must have the string world value on it. Otherwise this place will have tokens but not the ones required by T1. So let's put a token which is different from this string and see what happens. So let me put this thing away. Let's say one USA, and we have a token but the transition is not enabled. How do we know it is enabled or not? Let's put a token hello world over here and see what happens. So we put a token world over here. Since it's the same token required by the arc expression, you see that this T1 is now enabled, and the indicator for that is this green boundary around this T1, and now this transition is ready to fire. Let us now fire this transition. For that we would need a tool palette which allows us to run a PetriNet model. That tool palette is called simulation. Let me bring it to the workspace, rearrange some of these binders, and here is the tool palette which has all the tools required to run fast forward, one step at a time, stop a simulation, or rewind a PetriNet model to its initial state. So play around with these tools and see how do they perform. The first tool is the one which allows us to take the PetriNet to its initial condition, rewind it. It's already in initial condition. The next one is the one which allows us to stop. So if we have a large complex net running different transitions concurrently at the same time, and we like to stop it somewhere in the middle of the simulation, this is the tool to use it. We will use this fourth tool which executes a single transition at a time. So let's do it. We pick it, apply it on this page, and you see that the transition T1 has fired. When a transition T1 fires, it consumes tokens from the input places, and we saw that P1 and P2 have lost the tokens that they had, and this transition produces new tokens in the output places. And this is a very important point to note, that when a transition fires, it consumes tokens from the input and produces new tokens at the output. To illustrate this point, let me rewind this net and add a different arc expression at the output, which may have absolutely no connection to the input tokens. So if I say hi there, what happens, the input tokens are simply consumed by T1, and the output token is produced by T1, and the value on that token is determined by the arc expression at the output. So let me run it one more time to show you that, and you see that the new token has hi there as the value on it, because this is the value given to it by this arc expression. Let me rewind it one more time and tell you something more about the tool palette we have for simulation. This fifth tool in this palette executes a number of transitions before stopping the simulation. So the one we used allows us to fire a single transition at a time. The one right next to it allows us to run a Petri net model for a number of steps, and those steps are specified over here. It's a small integer number that is written right below it. So for example, if I put 100 over here and apply this tool, the simulation will stop after 100 steps if there are 100 steps enabled in a Petri net model. Otherwise it will stop before that. Then finally we have this last tool, which is a fast forward tool, and again it has this number attached to it, which is user defined. I can also put 100 or any number that I like. This tool suppresses the graphics, runs the model for those many steps before stopping it, and only displays the last state, the configuration of tokens on the Petri net structure after those many steps. Before we move on to more advanced features of CPN tools, there are certain points to be noted. The first one being the case sensitivity of the inscriptions. For example, if I write hello over here with a small h and see what happens. Now T1 is not enabled, although I have a token in P1 which says hello, but since it starts with a lowercase h and the arc expression requires a string hello with a capital H, the T1 is not enabled. A hello with a small h is a different token than with a capital H. If I change this arc expression and make it start with a small h, then you see T1 is again enabled. The second point is that the type of net we have developed in this example is called an arc constant net. Since the arc expressions, the ones that we have put on these arcs, are all made of constants or actual values from the color set string, therefore they are called arc constant nets. In the next part of this video, we will declare variables belonging to the color set string and use them on arcs. In that case, we will be moving from an arc constant Petri net to a full-fledged colored Petri net.